Now let's learn centripetal force. You remember in previous video I told you in circular motion the direction of motion is constantly changing. Why? Because velocity is a vector always tangent to the circular path and it's changing its direction. So the object accelerates and there must be a force acting on it to cause this to happen. According to the Newton's second law, F equals ma. And if I take the acceleration to be centripetal acceleration, accordingly the force is centripetal force. You might have two alternatives for that, as acceleration is going to be v squared over r or r omega squared. The centripetal force accordingly will be mv squared over r or mr omega squared. But the question you need to ask for any situation involving circular motion is what force provides the centripetal force in that situation? The direction of this force must be along the radial line between the object and the center of the circle. Here I have two alternatives for Fc. And Fc is a role. Who is the actor of this role? You should find it in every single problem. Let's consider a few cases. In satellite case, satellite is an object orbiting the Earth. Earth is the center of this rotation, and here I have a satellite, this orbit of the satellite. Satellite is moving in vacuum, so there is no force acting on that except gravitational force. So here, gravitational force is substituted for Fc. The other is the atom. Negative electron is revolving the nucleus. Nucleus is positive. Always between a positive and negative particle, there is an attraction which is called Coulomb force or electrical force. So here I will substitute Fc for Coulomb force. Rotor. In amusement parks, there are very huge rotors, revolving cylinders. People stand here inside the cylinder, and the normal force can keep this Fc or provide this Fc. The other one is going to be the car in roundabout. You know, the car in roundabout always rely on friction. Without friction, there is no possibility to have that circular path. So here I will substitute that for friction force. Let's make a relationship between some quantities. On top of this pyramid, I have omega, the angular speed, and here linear speed, r omega. And then centripetal acceleration, r omega squared, or let's write it as r omega omega. And finally, if you multiply it by mass, it will be mr omega omega, the centripetal force. A cyclist rides along a circular track of radius 100 meters at a constant linear speed of 36 km per hour. This is not in SI units, and I am going to convert it to SI units. 36 divided by 3.6 is going to be 10 meters per second. Total mass of the cyclist and his bicycle is 80 kilograms. Find the centripetal force acting on the system. Okay, let's do it. Here the centripetal force could be mv squared over r because v is given. And then I plug in the values. 80 kilograms for the mass, v is 10 meters per second as I mentioned, and r is the radius of this circular path. It's going to be 80 Newton. Which force is providing that? I told you it's like a car in a roundabout. It's the friction force. A hammer thrower in an athletics competition swings the hammer on its chain round 7.5 times in 5.2 seconds before releasing it. The hammer describes a circle of radius 4.2 meters and as a mass of 4 kilograms. Assume that the hammer is swung in a horizontal circle and that the chain is horizontal. Okay, here I have a horizontal chain and the tension of the rope is applying the centripetal force. Calculate for the rotation part I, the average angular speed of the hammer and the average tension in the chain. Tension is exactly the centripetal force. Okay, first let's go over average angular speed. Here omega is delta theta over delta t. You remember it was 7.5 turns. So each turn is going to be 2 pi and the total angle traveled in this rotation will be 7.5 times 2 pi. Downstairs is the time for this rotation, 5.2 seconds. So it's going to be 9.1 radians per second. The last part is Fc. Actually, Fc here is supplied by the tension of the chain. So it's mr omega square, and we already found omega. Let's plug in the values. 4 is the mass, 4.2 is the radius, and this is omega square. 1400 Newton. In everyday conversation, it's very common to use centrifugal force. It's not a real force, it's a fictitious force. I have a video in dynamic series, dynamic playlist, and if you watch it, you will learn what the fictitious force is. But in short, I will explain what the centrifugal force is. Basically, if you are a passenger of this car, you have a tendency to keep a straight line motion. It's called inertia. But there is a force always acting on you, which is called centripetal force, to keep you on the circular path. Because of that, you always feel a centrifugal force, a fictitious force pulling you out of the circle. It is not real. It's just your feeling because of inertia. And you know that we are not allowed to consider the problem in perspective of a person in the car, because in the car you are in an accelerating system and it's a non-inertial reference frame. So it's not a proper system to consider the problem. Please do not use centrifugal force in physics. Thank you for watching this video, and thank you for being with me. See you.